Welcome to Deep. You're at Cloud Computing and Smart Infrastructure. This is senior level ACE course. This is the second week. My name is Leon-Garcia. Let's start off by getting to know each other. Okay, we'll do a couple of activities, and then we'll do a small survey, and then we're going to go to a tour of a server room. Okay, so explain in 3 or 4 sentences who you are and where you're coming from. Let me see. Where are the counselors? Let me put them on the spot. Or should I start first? Okay, I'll start first. Leon-Garcia from Beirut, Lebanon. I'm a PhD candidate in electrical and computer engineering. I'm second year. Doing my master's was in vehicular networks. And now I'm doing research more in intelligent transportation systems and connected vehicles. And now you're going to tell me a few things about you. Let's start with the counselor. So welcome to all of you. The course is going to be interactive. There's a lot of things that you'll figure out and you'll teach me. And then if there's any additional things that I can add, I will add them. So we need to get to know each other. That's why we're jumping into activity 2. 3 unique things about you. So they could be good things, bad things, things that no one would think of. But again, I'll start first. Let's see. Okay, first one. It's not going up. Okay, I used to play as a center. Does anyone know what basketball is? Who has played basketball before? I used to play as a center. I'm not tall, am I? So funnily enough, when I was 11, I was almost the same height as now. So I was tall for my age. I used to play as a center, and no one actually believes that today. And I used to rebound a lot. Okay, I love ketchup a lot. I put it on everything. Pizza, eggs, whatever you might think of. And last thing is, I wanted to be a lawyer when I was young, and I'm an engineer, and I love it. Okay, so let's start with you. Be as interesting as you could be. This is where your group, your class will get to know you. Be creative. Start. Okay. Course expectations. Here, I want to know what you want to learn, and then I'll keep the next thing first as a surprise. Why are you here? What do you expect to learn? Come on. I'm not going to ask every one of you, but tell me so that I know what you want to receive from me. I've read what you have written, some of you, but please try to share. Why are you here? What do you want to learn from this course? Yes?
I'm here to explore this field.
Okay. Exploring this field. Yeah.
I want to see what this course relates to engineering and how this course is a part of engineering.
So, to see how this course is related to engineering. Any other reasons? Someone just wanted to come to Toronto? Run away from home for a week or 2? Any other reasons? Let's see. I read some interesting things. There were quite a bit of you who wanted to be engineers. They wanted to figure out what discipline in engineering to do. So whether to be an electrical engineer, a mechanical, an aerospace, a civil, so on and so forth. So any other reasons why you're here? Or should I jump to what you're actually going to learn? Okay. So course objectives. These are formal ones and then the informal ones come in. You're going to understand what cloud computing actually is. You're going to experiment, just like a pro with cloud computing. So Today in the afternoon, we're going to have an activity on the Amazon cloud, and you're going to use a Linux server, set up your web server on top of it, and put your website, put your web page, all of it today. And you can host your own website on it, basically. That's what professionals do. Learn about what makes infrastructure smart. So the course is called Cloud Computing and Smart Infrastructure. Tomorrow we start with smart infrastructure. You'll know the different components of smart infrastructure, and you'll know exactly what makes it smart. You'll learn about smart grids, and we have a guest speaker tomorrow about smart grids, how game theory is used in smart grids. So that's going to be interesting. Learn about smart transportation, and you'll get to experiment with smart transportation techniques. We're using a simulator, a traffic simulator on Wednesday and on Thursday and Friday. That's why I was telling you to sit on the second computer, because you'll be working in groups, and the licenses are limited, and it's because it's very expensive. But you'll get to see every single car and vehicle and bus moving, and you can change things and see how your changes will make differences. So you'll get to experiment with those, just like people in the industry, just like traffic consultants to ministries to cities. You'll be using what they use, and you'll be solving a smart transportation problem, and you'll be presenting your work. So just like I'm speaking now, you'll get the chance to speak several times, and you'll be presenting on a couple of the days. Okay, informal. Any guesses? Okay, let's see. Okay, you'll be shocked, you'll be surprised, you'll be excited, hopefully. You have to be careful. You have to be careful from him, first of all, because he knows Taekwondo. But you also have to be careful because there are things in this course that are going to actually fool your intuition. Intuitively, you'll think this is going to happen, but something else is going to happen. And you'll see those, especially on on Wednesday. You'll get to know your role in the society, your aspiring engineers. You'll get to know how your actions contribute to society, and we'll do some nice activities on those, involving running downstairs to the bottom of Galbraith. You'll find out Wednesday morning. You'll be thinking like an engineer, solving like an engineer. You'll be creative, and you'll be thinking outside of the box. Okay, you'll be finding creative ways to solve things in different ways, and you'll actually be getting flavor of electrical and computer engineering and transportation within civil engineering. So the first couple of days are going to be mostly electrical engineering, and days 3, 4, 5 are going to be transportation. They're going to be intelligent transportation systems, which includes people from computer science, from electrical engineering, and your traffic engineers from civil. So you'll have a good understanding of how different disciplines could work together, and that is what is actually happening these days. You'll have fun, hopefully. You'll make friends, and you'll be able to work in groups and learn from your peers. Okay, so tour of the server room. Let's get out and see things, right? Okay. Okay, so welcome back. We're not missing anyone, right? Okay, so after the server room, reflections, observations. What do you see in the server room? Servers. What do servers include? Hard drives, which are used for memory, processors that do processing, computations, RAM, memory. What else did we see?
Fans.
Fans. Why do we need fans?
To cool it down.
To cool it down. Why?
So it doesn't overheat and melt down.
Because it's doing so much processing, right? What else? How did you reach these different resources?
They're all connected into one hub.
They're all connected. So communications, right? You had wires going to the hubs, and then the hubs are connected to other routers, and then routers go somewhere else so that when you're at home, you can access your email. What else? Okay. Let's see. Storage, computing, those are the main resources. Fast communication between all of those, right? You click something, you want it to go through the firewall, through all your wires, your hub, your switch, reaching all of those different nodes, and letting your process be run the way you want to. If you think about the delay also of accessing it from somewhere else, you need all of that to be within microseconds, right? Within milliseconds, so that you don't actually feel it, right? You want to press send, and you want the send to be done in what? Half a second, quarter of a second? Okay. So fast access to systems. So your memory, your read and write, remember we were talking a bit about memory there. You want to make sure that you inputting something that is going there and being written in the hard drives inside is being done fast. And when you want to read something from it, it's being done fast. For example, if you put in your username and password and that is coded and then sent, and you want to have approval of it or checking for it before you can actually go through, you don't want that to take ages, right? You want that to be done fast. That's why you need to be able to do this memory write, read and write fast. So if you think of a data center, which is a bigger version of what we saw, you have computer systems, telecommunications and storage systems. You have, of course, power we said is important, so you need backup power supplies. If there's a power outage, everything could go down except of what? Your server room. Your server room can't be down. I remember this. I used to work nearby a server room in American University of Beirut, and sometimes when there were power shortages and it went for too long, I would go to the server room. Why? It was cold. Everywhere else was hot. The only thing that was working was basically the server room because they had backup power supplies. You also need data communication connections. You have your security devices. We talked about firewalls. You want your resources to be secure, and in order to reach your resources, you have to go through firewalls. You also need physical locks, as we also saw on some of the servers. Environmental controls such as air conditioning, fire suppression. You need to make sure the pressure and everything is done correctly. Okay, so if you think of this, if you think of what we saw and imagine it at a very, very big scale. Okay? So imagine 100 times bigger, 1,000 times bigger. Imagine scale of Google, Facebook. What changes? What are the problems that you would have? Yeah?
You have a lot more information, so if someone hacks in, there's a lot more danger involved.
Okay, you have a lot of more information, so you have bigger security issues. Other than that? Bigger server rooms, that would mean more power, right? It would be more power, more cooler rooms. Other than that, with respect to the resource that you mentioned, yes?
Worldwide server rather than a small area?
Yes, so you also need servers in different locations, right? Because if you're accessing from Europe, you don't want to go and fetch that data from North America. You want a separate server which is in Europe in order to get that information. So you need duplicate servers in different locations depending on where your users are. Storage. We need far more storage, right? Far more data. Think of all the pictures that you have on Facebook, all your albums. Where are they? They're on servers, right? And if you press next, you are supposed to see the next picture immediately, right? So there should be duplicates of it in different servers close by, which you can access. Computing power. You have all of those servers now, far bigger, so you need far more computing power. And now you start having communications issues. Remember that box with all the yellow wires in it? Okay? Now imagine that times 100. And then imagine pulling out one of those wires and trying to figure it out. It's not going to take you a week. It might take you a month to find out where that wire was. or it could just be that over a certain period of time it malfunctions. So you have all of those issues, and you need to make sure that they're well connected. Redundancy is required. You'll need more time to fetch the data unless you have your multiple servers in different places. Authentication. So security measures need to be well put over those big spaces because you don't want someone to tap in. Although it's bigger, you want to make sure that you have different firewalls to different places, and when you go in, you're only accessing what you're required to access. Let me give you this example. When I was learning my computer security course here in the fourth year, here in my graduate studies, it's a fourth year or grad course, they gave us this example. A few years ago, when security measures were not as strong as now, there was a person who had a bank account. He had $400, $500 in his bank account. What he did was he made copies of his debit card, 1,000 of them, okay? And he had a network of friends, 1,000 of them, went into different places all around the world, and within 4 seconds, they each took out $400 from the machine. Okay? At that time, the technology wasn't good enough to be able to take out the $400 and then no one else can take the $400, right? But because it is happening within a very, very, very minute, short period of time, they managed to take out $400,000. You had 400, you took out $400,000. Okay, so this is not something small. This is not this is a big problem, and this has happened. That's why there are different measures now. Your debit or MasterCard or Visa or whatever are getting far more advanced. They have chips in them. They have various security measures, and the moment you take something out, no one else around the world could take that amount out within like milliseconds, to say the least. So this cannot happen again. And now we're talking about banks that have huge data centers, and they have to have them all around the world, and they have to have fast communications between different countries in order to make sure that something like this doesn't happen again. Okay, Mark, can you imagine the scale of how big this problem is? Okay, so now let's talk about something else. The ones who are from Canada might know this, but I'll explain it. So the concept is varying demand. You have demand varying throughout the year, throughout the day. The demand here is for networking resources. Okay, so Boxing Day. Who knows what Boxing Day is? So what is Boxing Day? Out loud to everyone, to the visitors to Canada.
The day after Christmas.
Okay, what happens in Boxing Day? Okay, so it's the day after Christmas. So it's the 26th of December. And this is celebrated, it's a secular holiday. It is celebrated in Britain, Canada, New Zealand, and some states of Australia. So what happens during this time is you have crazy lineups starting at 5 a.m. at all your major stores. You have prices going down to 50% to 30% of the original price. This happens once a year. And people who have been waiting to buy their stuff don't buy stuff for like 2-3 months until Boxing Day because they're sure that their iPad, your iPod, your laptop, your HP, whatever it is going to be less expensive. That's in terms of electronics. And also your clothes are going to be more expensive. So you have people going to shopping malls, lining up in the morning, going and grabbing like different dresses because they don't know which one is actually going to fit. They go try them, and then they're fighting over that's mine, that's mine. But that's not done electronically. The part that is done electronically, the shopping that is done electronically is mostly for electronic devices, those type of things, because you don't need to go test them whether they're going to fit you well, right? You know the specifications. You know what you're buying a particular brand. You know it's going to work. If you're buying a flash drive, it's going to work. The 32 gigabyte one goes down to like $4 on Boxing Day. Okay, you order 10. They're going to be shipped to your place. You don't even have to wake up at 5 a.m. You'll be celebrating Christmas, then you'll take a long sleep, and then the things will appear to your doorstep at I don't know, January 3rd, 4th, so it's still fine. So is it clear what Boxing Day is? It's really important that you understand what's happening here. Okay. So you have dramatic price reductions. This is just a number that I got from Wikipedia. In the UK in 2009, it was estimated that up to 12 million shoppers appeared at the sales. 12 million. That's a huge number, and those are the ones who are there present. You're not counting the ones who are shopping online. One of the things that just occurred to me also happens is you're at a store and you're trying to buy a device. They would tell you, yes, it's available. It's available there. Then you show up and then it's not there. Why? Because they don't have their networking done well. The redundancy, the same type of problem with the bank, right? Their servers are not being updated fast enough to make sure that that device is available. So most of these sales are now done online. Now, think of it from a data center perspective. Okay? Think of these, I don't want to give brands here. Think of one of the big electronic shops, and they have to have servers in order to handle Boxing Day sales. So what should they do? What do they need? Imagine all the transactions that are happening at the same time. 2 million people trying to buy the same device, and they have a 2,000. Yeah. A lot of memory, right? A lot of storage, a lot of processing, crazy authentication, because you don't want your system to crash and all of a sudden hundreds of LCD TVs get sold for $2 each, which happened a couple of months ago. So you have to have the extra storage and computing devices available, right? Now, they have this. Let's say that let's assume they have this for Boxing Day. What do they do with this during the rest of the year? Exactly. Nothing. It just gets wasted. It sits there, right? If they have it. So what is the problem that we have here? Wasted money, wasted power, right? You need to have those up and running, and not a good allocation of resources, right? So I'm just putting a note here that these high demands happen very, very rarely. So like the Boxing Day type of sales happen once a year, at most like twice or 3 times. That's it. During the rest of the time, you don't have this peak demand, right? The peak demand goes back to your normal demand. Okay, what about smaller companies? What can they do?
Rent a server for a day? Like
Rent a server. Okay, we're going to reach there. So if they don't rent a server, if they're supposed to actually buy one and maintain it, it's going to cost them money. But they don't have resources to buy that, right? So they can't compete because they don't have those resources ready. And basically, you'll be less willing to trust a smaller company with stuff like this because you want to make sure that things are not going to crash. When your transaction goes through, you want to actually make sure you bought that device before anyone else. Why? Because it's cheaper during Boxing Day. Okay, so what is the problem? The problem is how to deal with this varying demand. The peak demand that you have and the demand during other times. So the term that is common is called overprovisioning, which is taking a safer bet, having the resources ready for the peak demand, which is, example, Boxing Day. So having all that you need for Boxing Day. But that's not the only solution, right? As your colleague mentioned, you can rent resources, right? That is exactly what cloud computing is. And I'll explain that in a minute. Okay, so what about just using what we need when we need it, instead of having things sitting there, not being used, being wasted? So rent the resources you need when demands are high, and return them when demands go back to normal, right? Why can't we do this? Doesn't this sound cost effective? Don't you think? let's see. Has anyone heard of party rentals? Okay, I'll give you examples. You're having a huge party. So, I don't know, one of you is going to host all of us tonight for dinner. They're going to have a party for all of us. What do you need? Unless you have all of those resources at home for 25, 30 people, you would rent them, right? So catering companies could provide this, or party rental companies. So chairs and covers, tables, tablecloths, silver and flatware, dishes, glassware, table accessories, outdoor accessories, the food, right? You could rent all of these things. You're not expected to have 100 glasses for different types. I don't know, for wine, for juice, for kiddies juice, I don't know. You're not supposed to have all of those things. You're not supposed to have hundreds of large plates and the dessert plates and different cutlery in big quantities. So what would you do when you have a big party? You can rent them. If you just go online and search for this, there are so many places where you could get this. Okay, so instead of buying all of these things, you rent them for the party and then you're returning them basically. So buying them and storing them will cost money, will take out space, and the ones who live in Toronto, you know how much that costs. Not to mention power. Now I guess some of these need power. I can't remember which ones. At least the ones in data centers do. So